Okay, so today we're going to look at 4.5, proving triangle congruence. Again, so in the last section we learned about two postulates, side, 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 and side, angle, side. And then today what we want to look at are other combinations that might work. So other shortcuts to proving two triangles congruent. So the first postulate is for today is angle, side, angle congruence. That's ASA. So if two angles and the included side, so this time we're talking about an included side of one triangle, they're congruent to two angles and the included side of a second triangle, then the triangles are congruent. So if we look at these two figures here, so here's angle T, that's going to be congruent to angle G. Angle R is congruent to angle C. So TR is considered the included side. So it's the side that is part of angle T and part of angle R. And then that's congruent to CG, which is, again, this is the included side. It's part of both of the angles. That's what's that is what makes it the included side. So the triangles that are congruent, again, we can list the first triangle any order that we want. Let's say TRW. And then I just need to make sure that I match up. So angle T matches with G, R matches with C, and then H. So that's angle, side, angle. So we are going to do the following proof, and we're going to use angle, side, angle postulate. Okay, so we're going to start with segment CP bisects angle BCR and angle BPR. So we're going to write in given. Now, just like the lesson that we did previously, what we're looking for are three things. In this case, we're looking for two angles and the included side. Okay, and we're going to have to use the given information and also maybe refer to the picture. Now, if CP is bisecting angle BCR, that means BCR is cut into two congruent parts. So let's look at that angle first. So we have BCR is this angle. So if PC is bisecting it, that's going to make these two angles congruent to each other. So we're going to say angle BCP is congruent to angle RCP. And we need a reason for this. And again, we look back at the words that are used. The word bisect is used. That's actually the definition of an angle bisector. So we had a segment bisector and an angle bisector. This one is bisecting an angle. So that's what the definition. Now it's also bisecting angle BPR. So BPR is here. So that's going to make these two angles congruent to each other. Now they're not all necessarily congruent to each other, so not all four, but these two are. So I'm going to put angle BPC is congruent to angle RPC. And it's the same reason. Now if I look at my statement so far, here's a pair of angles, here's another pair of angles. So all I need is the included side. Well, if you look closely at triangle BCP and triangle RCP, they actually share this side. This side happens to be the included side. If you notice, here are the two angles. This included side is part of both of those angles. So I'm going to write that down. So statement 3 is going to be CP congruent to CP. Again, that's my pair of sides. So my reason is reflexive property of congruence, but you can just write reflexive. And we're actually finished. So for step 4, we have triangle BCP congruent to triangle RCP. And our reason is angle, side angle. Now, we get the reason by looking at the picture, and that's why I always label everything. We don't get the reason, based on the order in which I wrote my statements. Okay, so that's why we have to look back at the picture, and we should recognize that it is angle, side angle, and no other, option for, the letter, the order of the letters. Because what we're going to learn next is a theorem. This is angle side congruence, and the order is important. So you'll notice this time this is saying if you have two angles and the non-included side of one triangle are congruent to the corresponding two angles and side of a second triangle, then the triangles are congruent. So basically what we're saying is if you know if you know two angles and one side are congruent, you know the triangles are going to be congruent to each other. It all depends on where is that side. Is it included? If it's an included side, our reason is angle, side, angle. If it's not included, then it's angle, angle, side. And actually, if you write side, angle, angle by accident, that's actually fine. It's the same thing. So here we have our picture. We have K congruent to A. We have angle L congruent to angle B. And then AC is congruent to JK. So I'm going to write triangle JKL congruent to triangle CAB. And that's the angle, angle, side congruence. So we're going to write a 2-column proof. So we have RQ is congruent to ST, and we know RQ is parallel to ST. And we want to prove triangle RUQ and triangle TUS are congruent to each other. Now here we have a number of different options. So far, if you look at the first given statement, we actually have a pair of sides. And so for step 2, we have some choices. Well, we do have parallel lines. So when we have parallel lines, we're going to have those special angle pairs that are congruent to each other. And actually, we have two pair here. We have angle Q is congruent to angle S, and angle R and T are also congruent because those happen to be transversals. Now, if you didn't want to use both of those angle pairs, you may also recognize that we have vertical angles congruent. So depending on which angle pairs you use will depend on the reasons for proving the two triangles congruent. So I'm going to put in, since I already have it labeled, I'm going to write angle Q is congruent to angle S. Oops, not triangle, angle. And angle R is congruent to angle T. Now, you'll notice that I only used one letter to name these angles. That's because there's only one angle that I could be referring to at each of these points. So if you want to use 3 letters, that's fine. It's just not necessary. The reason for this, again, this is alternate interior angles theorem. And this gave us a pair of angles congruent. This gave us a pair of angles that are congruent. So I have my 3 pieces that I need. Again, I either need 2 angles and the included side, or two angles in the non-included side. So I have that. I actually have two angles and the included side, so I can make triangle RUQ congruent to triangle TUS. And my reason is angles, side angle. Again, if you just look at one of our triangles, you can see, hopefully, you have the two angles and the side is included. That's why it's angle, side, angle, and not angle, angle, side. Now, if you had wanted to use the vertical angles here at point right at T, or sorry, right at U, then you could have had angle, angle, side as your reason for the last step. So basically this brings us to a summary of all the different ways that we can prove triangles, two triangles are congruent. So we learned about side, side, side. We learned about side, angle, side. Today we did angle, side, angle. And finally, angle, angle, side. So there's actually one more that we're going to learn about, and that is what we call the hypotenuse leg. And this is a theorem, and we'll just abbreviate it by HL. This tells us if we have a hypotenuse. Now, if there is a hypotenuse, then we have to be referring to right triangles. So this says if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. So you'll notice here we have the hypotenuse of one is congruent to the hypotenuse of the other, and then one pair of corresponding legs. Again, this only works if you have a right triangle. So all the different ways that we have, we said side, side, side. We have side, angle, side. We have angle, side, angle. Angle, angle, side. And finally, hypotenuse leg. So let's take a look at these triangles here, and let's determine if we can make the triangles congruent and what the reason. So for A, I see I have a right triangle here and here, but I don't have the hypotenuse marked congruent, so I can't use hypotenuse leg. But if they're right angles, we know they're congruent. We can see here another pair of angles are congruent, and the side between them. This makes this angle, side, angle. So these are congruent. So yes, angle, side, angle. Next, for B, I have right triangles again. I don't know whether or not the hypotenuse of one is congruent to the other. So it can't be hypotenuse leg. And if we look closely, we have a pair of angles here and a pair of angles here. What are we missing? We're missing a side. If you notice all of these have a side, and of course hypotenuse leg, that both of those are sides. So if all I ever have marked are angles, that's never going to be enough information to prove two triangles are congruent. We need to have one pair of sides marked congruent. So this one, we do not know whether or not they're congruent. There's not enough information. Okay, for C, I see that we have right angles, and if you look directly across from that, we have the hypotenuse. Now, the hypotenuse happens to be a side that is shared. And then we have two corresponding legs congruent. So this is actually hypotenuse leg. Okay, so we want to prove the following. We have L is the midpoint of WE. Okay, so L is the midpoint of WE. and WR is parallel to ED. Now you'll notice that I have in my proof, I'm not proving triangles are congruent, I'm proving RL is congruent to LD. So my goal is actually, let's try to get the two triangles congruent, and then we can prove by corresponding parts of congruent triangles that they're congruent. So we want to get triangle WLR congruent to triangle ELD. Now we have nothing of congruent statement. There are no congruent statements in the given. So I want to look at what I am provided with, and that is we have a midpoint of WE. That means WE is cut in half. We know WL must be congruent to LE. The reason is midpoint theorem. That gives us a pair of sides. Remember how I said we always need to know at least one pair of sides. Now, L might be the midpoint of RD, but we don't know that for sure. That's actually kind of what we're trying to prove. We're trying to prove that RL is congruent to LD. So I have to just look at, it says it's the midpoint of WE, so only WE is cut in half. Now we also know parallel lines. WR is parallel to ED. So I know we have alternate interior angles are going to be congruent here. So I also notice we have vertical angles. So if you want to say vertical angles are congruent here, you can state that. But to make my proof a little shorter, I can actually come up with two pairs of alternate interior angles. So that would make my proof a little bit shorter. So angle R is congruent to angle D, and angle W is congruent to angle E. And we said that's alternate interior angles theorem. And this gives us a pair of angles, another pair of angles, and so we have 1, 2, 3 pieces of information. We have enough to prove the two triangles are congruent. So I'm going to state triangle WLR is congruent to triangle ELD, and now we need a reason. So we want to look back at the picture. We have two angles and a congruent side. Now, when you look at the two congruent sides, you want to consider, are they included? Are they between the two angles? Well, I have a parallel marking here, but that's not a congruent. Over here is the congruent. So it's actually the non-included side, which makes it angle-angle side. And now that we know the two triangles congruent, all their corresponding parts, and now we know for sure RL is congruent to LD, and my reason is CPCTC. Again, corresponding parts of congruent triangles are congruent. Okay, so for our next proof, two quick changes. I would like you to cross off the parallel part and add this perpendicular statement. Okay, so in this proof, we have AB is perpendicular to BC, and we have BC is perpendicular to CD. So basically we have right angles in here. And we also know E is the midpoint of AC and BD. And we are trying to prove AC is congruent to BD. Okay. So if we can actually get, let's say, if we can get this triangle, ABC, if we can get that congruent to this triangle, BDC, then we can get their corresponding parts congruent. So we really don't have a whole lot of information here to get those two larger triangles congruent to each other. So all we know are right angles and they share a side, but we don't have any other information about the triangles here. So our plan is to try to work with maybe two other triangles, get them congruent, and then use their corresponding parts. So I'm going to start with the midpoints. If E is the midpoint of AC, that's going to make AE congruent to EC. Also, E is the midpoint of BD. So these two segments are congruent, so BE congruent to ED. And this is going to be midpoint theorem. Now we also know, looking at the figure, that we have vertical angles congruent. So I'm going to use that. Angle AEB is congruent to angle CED, vertical angles theorem. Now that actually gives us enough information to prove these two triangles are congruent here. AEB and CED. So I'm going to write that down next. So triangle AEB congruent to triangle CED. And if I look at the markings that I have here, I have side, angle, side. Now the reason I want to get those two congruent is then their corresponding parts are congruent. So I can actually get AB congruent to DC. So I'm going to write AB congruent to DC, that is CPCTC. Now, how does that help me? Well, remember what we said in the beginning. We had perpendicular lines, so that's going to make right angles, and they also share a side. We're talking about the larger triangles ABC and triangle DCB. So I have a pair of sides. Now we have BC statement 6 is going to be BC congruent to BC. That's reflexive property. And then we're going to go back to the given, and we're going to use it. We're finally going to use those perpendicular segments. So if they're perpendicular, then we know angle ABC and angle DCB are right angles. Now, I will accept either definition of perpendicular lines or perpendicular lines form right angles. So I'm going to just write in here definition of perpendicular lines. And if they're both right angles, then they must be congruent. So I'm going to write ABC congruent to DCB. And the reason here, all right angles are congruent. That's one of those reasons from our list. And now, based on that, we actually have these two larger triangles are congruent by side, angle, side. So step 9 is triangle ABC is congruent to triangle DCB, is side, angle, side. And now finally, we can prove AC is congruent to DB, and the reason is CP, CTC,